Hello. So, this is going to be a tutorial about what object-oriented programming is, kind of how it's helpful and why you want to know it. The main issue, however, is I wanted to do this as a live stream, specifically so I could have students talking to me and we chat like we normally do and stuff like that, and it did not go well. It very much did. My YouTube, or not my YouTube, but my internet in general is just really, really bad. So I'm going to be recording this as a video, and I'm just going to upload it afterwards. I apologize if anyone wanted to see this as a proper live stream so we can chat and all that, but it's just it doesn't look like it's going to be happening. So let's dive right in. So I'm going to get rid of that. I'm going to start exactly from the beginning, from where I was before I started any of this, because, not going to lie, I had done like 12 minutes worth of video, and I'm a little annoyed. But I want to talk about what is an object before I get into like the values of object-oriented programming, because I feel like once you're actually seeing what object-oriented programming is, you will see why you would want to use it. But what is an object? Well, an object is simply a set of data, each having a name, and that set of data would have a specific set of functions known as methods tied specifically to it. And I felt that a really good way of representing that would be a car. So what normally goes in a car? So cars typically have a maker model, so I'm just gonna, is it make that would be Ford? I think it would be make is Ford. Cars have a color, at least mine does. Let's say that this is going to be a blue pickup truck. Why not, right? Everyone likes blue pickups, don't they? I don't know. And then I'm going to say it has a year of being made, and let's just go with the 2013 Ford blue pickup truck. We're not going to make it any more complicated than this. It's just going to simply be exactly that. Nice, simple. And if I wanted to treat this just like a typical dictionary, I would simply say car model, if I wanted to get the car model, and it's not a model, it's a make, and you can see it's a Ford. What if I wanted its color? Well, I'd simply replace that with color. Whoop. I meant to hold shift while hitting that. And if I want its year, there's its year. So that's pretty helpful until I want to make more cars, because I have to copy this dictionary every time just to make a new car. That's a little against what coding is. The whole reason we make functions is so we don't have to type the same code over and over and over. The whole reason we make objects is so we don't have to keep typing the same data and the same functions on those data and the same everything over and over and over. It is a way for us to abstract something and keep reusing it. And code reuse is exactly what a computer science student wants. Pardon my throat. It's a little scratchy. It's pretty early in the morning, at least for me. So let's take that car dictionary and let's make it a class. So I'm going to do this in the next cell. Class car would have a constructing function called init. You can also call this your initializer. And all it does is it makes your dictionary. It is going to take in whatever data you want to go in the car, and it's going to make it an object for you to use. So what goes in an initializer, you might ask? Well, every object has a dictionary. So you can think of a car being if we want to look at it more as a class, you can kind of think of it as nested dictionaries. And the first dictionary in a car is always the dictionary self. So if I were to show you car itself at year, whoops, there's no equal sign supposed to be there. So car self year still produces the exact same thing. However, this self dictionary would tie exactly to a generic object. So I can now rename this to car 2, or car 3, or car 4, or car 5, or car 6, or car 7. I can name that whatever I want, but it always has the structure of self and then data. And that's pretty helpful. So if we know self is going to contain all of the data about the car, we want to ask ourselves, what makes a car? Well, a make, a color, and a year. So we're going to have a make, a color, and a year. Now you don't actually have to call those make, color, or year because these are just placeholder variables. They're not what goes in your dictionary. Self is what matters. So we're going to say self.make is going to be strictly equivalent to that make variable. So our make key in the self dictionary, we want to make that whatever that variable was. So I could call this just M if I wanted. And see how M matches to M and make matches to the dictionary make. So I'm going to rename these just to make sure that that comparison is quite clear. So self.color equals color, and self.year equals the year. So if I were to take this exact same car object, but I make it a car, properly a car object, I'm gonna add a bit of space so that way it's a bit easier to read. What goes in a car? Well, a car takes in a M variable, in which is your make, so it's a Ford. It takes in a C variable, which is your color, blue, and the year of make. So if I did car O dot year, you can see I get 2013, exactly like if I were to call it from the dictionary. However, now I can make more cars in less space. It's as simple as just calling my car class over and over and over. Now this is pretty helpful, but it's even more powerful than that. Notice how in a dictionary, we can't specify that Ford isn't, say, 21. If I were to do this and I still say make, it will still print, it prints 21 with no error, but that makes no sense, doesn't it? It makes no sense because that should be a string. Well, in a class, you can do that. You can say if type of M is not equal to a string, raise a type error. Incorrect make input. So now if I tried to make a car with a make 21, I'm sorry, how is this not correct? Ah, that is why it's not correct. I didn't type the word if. But notice, now, because I tried to make a car with 21 being its make, Python's like, I want that to be a string, honey. It's already way more powerful than what a dictionary is. And I even specified it's a type error, incorrect make input. And this is not just restricted to one. I can do this for all variables if I so choose. So now I have specifically said a car must be a make of type string, a color of type string, and a year of type int. So I cannot make a car a Ford 12 2013 because that is an incorrect color input. I additionally cannot make a blue 2013 but as a string. That's going to say incorrect input. I could also typecast Y, the year, to be an integer. So notice how 2013 is completely valid, but if I now typed pineapple for the year, well, pineapple can't be turned into an integer. So that's also problematic. I'm gonna strictly say, however, you must be putting in integers. Now this is pretty cool. And already you can kind of see why this is pretty valuable. But there's more. Oh yes, there's more. Let's say, back up here to our original dictionary example, I want to make a function. So def rand function, and it's supposed to take in a car dictionary. Whoops. And what it does is it does for key in dictionary, not dictionary, car dictionary at self print car dictionary itself at key. So let's say I want that to print every item of a car. So if I were to call print rand function on car, boop, you can see there's the make, the model, the year, and I don't want it to return none. Why is it returning none? Where is that printing none from? I don't know where that's making or printing none. Oh, I know exactly where it's. Yeah, it's the return value. So I'm just gonna do that. So that way it doesn't print anything. But because I didn't need to print that actually, because this prints for me. But you can see how this is kind of valuable. It's printing all of the information in a car. Well, I can actually define that here. And there are going to be two ways you could do this. I could do rand function exactly like I did earlier, and I can take in the self dictionary that is the car. And I could do for, and you really got to think, well, how do I loop over the keys of an object? And you could simply Google that if you wanted. Object loop over keys. I should specify Python, eh? So if I did loop over object.self, oh look, here's a random article. Let's take a look at the article, see if he has any code. I don't see any code yet. And if we look, so he uses .iter and .next. Personally, that's not what I really want. So I would have to actually say print self dot make self.year, self.color. Now I could call rand function on the car object, and it prints all that data. However, there's another way you could do it. Print is a function that automatically checks what object it's printing and converts it to a string. So if I overloaded the string item for this object, so string is basically me doing this. If I called the string function on my car object, I can change what it returns. Self.make, self.color, and self.year. If you have not seen this notation before, this is called an F string. And now, if I ran that, you can see prints Ford Blue 2013. And that's all I wanted it to do. So you can define functions that only apply to your car object. And that's pretty dang powerful, not gonna lie. Let's say I wanted a function called age. That is not how you spell age. That's still not how you spell age. Now, of course, every function has to take in your self dictionary. That is the object you're calling it on. And all I'm going to do is self.year plus equals 1. And I'm going to specifically return self, so that way I can do something like this. If I do car.age and then I call the string function on it, I need to make sure that I return self, or else this won't work. And I'll show you exactly why that is. So see how it aged by 1 year. If I comment out the return self, there's no object anymore. .age increments the year, but it doesn't return anything. It just says, okay, your dictionary is updated. Oh, you want the dictionary back? You didn't ask for that. I'm not giving you the dictionary back. I'm just going to update it for you. But if I still call string car O, the car has been updated. You can see the car has been updated. It's just, it won't print here. There's no reason for it to print here. You didn't ask for it to print here. But if I ask for it to print here, well, because it's string and string back to back, I have to specifically print both, and I just want to show you that print automatically calls string regardless, so you don't actually have to say string in the print function. That's just something I do. It's kind of my own, like, really in-depth explanatory look. So that's a car, both as a kind of dictionary and as a reusable class. And the whole point of classes is so you get that reusability. So let's take a look at a human being, something a bit more complex. So I want to also look at subclasses, or class extension. And that's going to be what this example is for. Because I am a person, but I am not the exact same as every other person. So a person will always have certain aspects, right? What makes up a human being? Looking at me, what is something that is constant between all of us? I have skin. I have a skin color. I have a hair color. I have an eye color. I have an age. Every human being has an age, regardless of what we want to say. We all have an age. We all have a. I'm not going to do weight. That's a bit personal. Actually, I'll do weight purely to demonstrate something. So, every human being would have And I'm not going to be making this too complex. I'm not going to type check anything or anything like that. If you wanted to, you could. Skin, hair, that's not how you spell I. We have an age, but remember how I said you don't want your weight just publicly on display. That's kind of like the big no-nos of talking to women, right? So I just need to make sure I have this correct in my head. So there's something called private variables in a Python class. And you would simply do a private variable by giving 2 underscores to the beginning of your attribute name. So you can now see that self.weight is going to be hidden. No matter how hard I try, I won't actually be able to call it. So let's say I make a person, a Mark, and he is going to be a person, and let's make a Mark, shall we? I am white. I have brown hair. I have brown eyes. I am currently 19 years old, and I am definitely over 200, but let's not share that. So if I called mark.skin, you can see it prints white with no problem. If I call mark weight, there's no such thing. Ooh. But it's still in the dictionary. I just can't access it. But let's say I have a little function called getWeight. And I wanted to do return self.weight. So if I do mark.getWeight, boop, it works. The class still holds that information, but it's going to hold it privately. It's not going to show anyone else that information. Now, what's wrong with this class? Well, like I said, I'm a person, but me and, let's say, the professor, Nick Moore, we're not the same person. And you can specify to the point of getting ridiculous, but let's just let's look specifically at genders, or not genders. Let's do sexes, because the terms are different. When you are born, you are either male or female, just in a general abstract sense. I don't want to look at gender arguments or anything like that. I support whatever you want to identify as, but let's say that you can either be a class male or a class female at the start. And this is specifically going to be for when you're born. A class male, however, well, a male and a female are just people. So this says that class male extends person. It is an instance of my person class, but it's going to be a bit more specific. So what should go in, and I just accidentally deleted that. So what should go in the init function of a male? And that's a unique argument. So I still want to call the parent superclass. I still want to make sure that I am a human being. And I can never remember if it is underscore super or if it's just super. I am learning too many languages at the exact same time. It is just super. Okay. So, super is another way of typing. So I'll show you both ways you could do it. I could call person self, and that is perfectly fine to do because and a male needs to take in, because men still have all of these things, right? However, I could literally call person self, or I can make it a bit more abstract. I can call super init, and then I'm pretty sure you don't have to give it self. I didn't actually read that. That might have been valuable to have read, but hey, let's experiment. However, I'm not done first. I want to also add self.sex equals no, equals male. So if I make Mark a male now, and I print my sex, bow chicka bow wow. Whoops. I should just make female as well, because I can't have the wonky indentation. Boop. So yeah, I am a male. I'm calling the init on my super, so I still have everything else that a male does. If I look at my mark.skin, I'm still white. If I look at my hair, I'm still brown haired. If I do get weight, I'm still 200. But I also now have access to my sex. Ha. So I'm everything that makes up a person, but now I am a more specific person. That's pretty helpful. That can get actually really helpful if you're trying to, say, make a video game. Because, yeah, you would have a class player, but player 1 and player 2 aren't the same kind of. Maybe one chose a female character and the other chose a male character, and you want different stats tied to males versus different stats tied to females, and it's still too early in the morning for a Pepsi. Dang. I was hoping more time had passed. Ha! Oh well. But you get the general idea, and perhaps doing a person isn't the most, perfect example, because at the same time, I could have literally just did self.sex, and I could have, I didn't need to do any of that. But you want classes to be as abstract as possible, because you want to be able to inherit from them. If you ever need to change a class, you don't want to have to change all this as well. I don't want to ever have to change Mark just because, oh hey, we've discovered a third sex. There's now male, female, and Gormagon. And now I need to say that, well, male or sex could either be male, female, or Gormagon. I don't want to have to update Mark now. I just want to be able to say, cool, leave him alone. I'm just saying this is now a new possibility. And that's kind of the value of class extension. Now, example 3, which I can't do. This is an example exclusive to the students at McMaster. I can't go showing course materials or test solutions outside of the current course. So, although this video was meant to help you and give a very basic overview, this was not meant to be in depth. This was meant to give you an idea. However, this next example for the students at McMaster is straight up going to be a question from a test, and I'm going to do it start to finish, every part of it. I'm going to read the question exactly as they were given, I'm going to code the question, and I'm going to give my general step-by-step walkthrough of doing this. And it's going to be, hopefully, really helpful. But yeah, if you guys did enjoy this, or if you guys want anything more regarding computer science stuff or coding, because I am a computer science student. I do a lot of coding. I very much enjoy coding. You could always check out my GitHub, Astro Coding, ASTROCODING. It is the same icon as my YouTube icon, so you should be able to find me no problem. But yeah, if you guys enjoyed this, I can always do more of it. I really don't mind. I've always wanted to actually make a proper like course in coding. I've never had good reason to, you know? But anyways, if you guys did enjoy this, I don't know if comments will be enabled, but if comments are enabled, slap a comment down below, or give it a like. I can see the likes, so I always like seeing the likes. It's a little geeky feeling. Alright guys, bye-bye.